All right. Good evening, everyone. Welcome to our monthly IEEE Women in Engineering public talk. I am Khandakar Nusrat Islam, Women in Engineering Group Chair. We have our Affinity Group Advisor, Professor Irene Serpolo. We have Vice Chair Aisha Rahman and Secretary Mohammed Sadman, who will be here today to moderate the question answer section in chat window. First, thank you everyone to attend tonight. The goal of this program is as a mission and vision of IEEE Women in Engineering to promote women engineers and scientists and inspiring girls around the world to follow their academic interests in engineering field. I am so pleased to be with you tonight and to have the chance to introduce our guest speaker today, who is going to talk to us about additive manufacturing of affordable, secure, and sustainable housing is support of a healthy global population. The speaker will introduce recent advances in digital construction to construct Earth projects and make new advancements for construction outside the Earth, such as on Moon or Mars. Wow, that is exciting. Our speaker earned her PhD in 2017 from the Pennsylvania State University. During her academic experience, she worked on a structure and application of additive manufacturing in construction. She was involved in multi-phases of the NASA Sentinel Challenge to build a 3D printed habitat for deep space exploration. Currently, she is working with a team of a variety of research at UNM, and her research interests include sustainable materials, structures, and construction practice by using emerging technologies to enable resilient infrastructure. Okay, without further ado, please join me in welcoming our tonight's speaker, Dr. Maryam Hojati.
Hello, everyone. Thank you, Khandakar, for your great introduction. And I want, before starting anything, to say my special thank to IEEE Women in Engineering Albuquerque section for inviting me. This is an exciting opportunity to just present part of my research for UNM students and the students in Albuquerque. So my name is Maryam Hojati. As she introduced me, I'm assistant professor in the civil construction and environmental engineering at the University of New Mexico. I chose to be a civil engineer. Here you can see my education. After getting 2 masters in different majors and programs in civil engineering, I received my PhD in 2017 from Penn State University. I started my new journey at UNM University in August 2019. After having experience in different fields of civil engineering, I started as a structural and bridge engineer. Then I did some teaching assistantship and also research assistant over different years. I was working as a visiting assistant professor at Bucknell University. I did my postdoc at Penn State, and finally I joined UNM in August 2019. This picture returns back to a head-to-head competition, NASA competition at Caterpillar Visitor Center in Peoria, Illinois in May 2019. This is a picture of me together with my supervisor and some of my teammates that I worked with them during my postdoc at Penn State University. And it was during a cool NASA project that today I'm going to share the story about this NASA project with you at the last end of my presentation. So before anything, I want to start to just introduce 3D printing as a manufacturing technique. Over the last few decades, the world experienced a new digital revolution in terms of fast manufacturing and fabrication of products and goods. New technology using computerized design and rapid production and communication all facilitate the industrialization and make the incredible change in most sectors of economy, including the health, education, energy, and food industry. One of these new advancements in the manufacturing is all about 3D printing or additive manufacturing. 3D printing is all about the process of making any three-dimensional object, solid object, from a digital file. 3D printing has been increasing in popularity in many diverse fields of industry, like aerospace, automotive, biomedical, energy, and food. It has been estimated to be the next industrial revolution because of the quick and cheap production of objects with simple to complex design and geometry. And it has been said to be the next industrial revolution. So the next industrial revolution, to be truly industrial, must produce things and products in the way that answer the broad categories of people needs. So this slide shows different steps to do 3D printing. So 3D printing is all about the deposition of the layers of material to form a three-dimensional solid objects. This slide shows different steps to do 3D printing, starting from generating the CAD model, the digital model, then slicing the model in proper direction because we have layer-wise fabrication of the material. Then we need to have some slicing. Then we should translate these digital model for the machine. And finally, we can layer-wise deposit this material to form the digital object. So in a summary, you can see different steps for 3D printing that is using for different industries, generating the digital model, slicing of the geometry in the layers in appropriate direction, translating and creating machine-readable code that could be read by the robots. And finally, layer-wise deposition of the material in order to manufacture the final three-dimensional object. Undoubtedly, one of the most exciting areas within the 3D printing space is the bioprinting. So since early 2000s, 3D printing technology has been studied in biotech firms. So they just try to deposit the layers of living cells to form any forms of organ or body parts. And this is one of the interesting part of 3D printing technology. Dentists also embracing these 3D printed goods in a rapid pace. So additive manufacturing has allowed dentists to make night guards, retainer, or crown. In fact, there is a whole market for the dental printer, and with any level of complexity or fineness, it enables them to make their parts easily and fast, and with the same cost. This novel technology also enables artists to create a sculpture that are technically complex and artistically competent, with a strong focus on the design of 3D printing or additive manufacturing. As you can see, we can make the sculpture in different scale, from tiny ones with any level of fineness, all the way up to larger scale. So imagine the day that you can download the CAD model of your dream ride, modify and customize it to your widest beams by considering some safety margin, definitely, and then send it to the friendly printer in your neighborhood. So this would be the future and what we are going to experience in near future. This slide shows one of the first 3D printed car, which was 3D printed by using carbon fiber. Food industry also affected with this new technology, and some of the fancy restaurants started 3D printing their food to attract more customers. 3D printing is allowing for any odd kind of food to come about. Shape changing or transparent pastas could be available at any store in near future. Perhaps if you have a sweet tooth, there is nothing like creating your own chocolate and candy treat. Creating chocolate molds has been traditionally complicated process, but by using this 3D printing technology, chocolate maker can just replicate any 3D objects in chocolate. NASA also has a competition, and it has invested about 125 grand for 3D printing of pizza for the space project. And you can see the result of this printed pizza in this slide. Additionally, 3D printers could allow for materials to be reused. This slide shows the 3D printed chairs and furniture, which are used by which are made by recycled plastic. So we can just take the advantage of this technology to reuse some of the material like plastic to make new furniture out of that. So far, we saw how new technologies make an incredible change in most of the sectors of industry in terms of manufacturing. But let's take a look at the application of this new and novel technology in construction, which is kind of my major. Construction is one of the largest industries in the world economy, and it's worth about $10 trillion globally. But construction has suffered for decades from remarkably poor productivity compared to other sectors. So while agriculture and manufacturing have increased their productivity 10 to 15 times since like 100 years ago, construction remained stuck at the same level of productivity over these years. And that's mostly because construction remained largely manual. So while other industry or manufacturing, they are making significant progress in the use of digital sensing and automation technology. But how about construction? Can we print buildings? Can we use this novel technology to do construction? Maybe if I ask you this question about like 7 or 8 years ago, you had some hesitation to answer this question, but nowadays there are so many companies, they are working on 3D printed houses. So definitely you might hear something about 3D printed houses, and the answer is yes, sure we can. Despite the vast potential for enhancing the productivity and effectiveness in the construction industry, unfortunately, this industry has taken very conservative approach and show very slow adaptation to this novel technology. So before moving forward, let's review the conventional practice, which is nowadays used for construction. Let's review some of the problems related to this traditional practice, the way that our houses were built or the infrastructures are all constructed based on that. So the conventional construction is generally slow. They are labor intensive and inefficient. This is a dangerous, it's one of the hazardous job in this country. It kills 10,000 people every year. And there are about 400,000 injuries every year. When COVID started 2 years ago, construction industry was in a big trouble because it's done mainly by labor and human mostly doing most of the work in the construction industry. So social distancing does not make sense for this industry. Construction, the way that it's done today, is very wasteful and it generates large amount of emission. And because of different trades that are involved in the construction industry, the process of construction is pretty corruption prone. It's also very costly and always is over budget. So what we have been focusing is finding a solution to this problem, and our solution basically benefit from advanced technology, the new technology. So if you see in biotechnology, since early 2000, they have started using the new and novel technology to do their manufacturing and fabrication, and they make a great advancement in terms of their speed and the quality of their products. But unfortunately, in the construction industry, there is some hesitation. So considering all of these needs and challenges, this construction industry needs to be transformed over time to reduce the construction cost and time. So the conventional construction is very slow. We need some sort of faster construction to be much more productive. To make the construction process much more environmentally friendly, to lower the amount of waste material, the amount of carbon dioxide emission, and improving the quality of the built environment. So one of the important area of revolution in the construction industry is related to the application of new manufacturing technique, such as 3D printing, or by using the autonomous equipment to lower the amount of human intervention to make sure that we can resolve or address some of these problems of conventional construction. So considering all of the problems that I mentioned in the previous slides, 3D printing holds a great potential to assist engineers and architects in the production of fast and economical and also complex models for the construction. So 3D printing is all about constructing free form structures. It will help us in building the structures autonomously in automation, improved automation in the construction industry. It reduces the cost, which is related to the labor and formwork. It enables us to fabricate any complex geometry, and we can reduce the amount of energy, we can have faster construction and lower the amount of material waste at the end of these projects. So, but as I mentioned, in other sectors of industry, there was faster adoption to accepting 3D printing as a fabrication technique compared to construction industry. I want to just review some of the hesitation that we have in adoption and embracing of this innovative technology in construction industry. The very first one, which is very important, and it's a big barrier in the adoption of 3D printing or additive manufacturing in construction, is all about the scale. Scale of construction projects is much, much larger compared to other industries. So when we talk about the bioprinting, we are talking about the printing of tiny body parts, which are not comparable with the size of buildings, with the size of bridges or towers. So one of the biggest hesitation and barrier in adoption of this new technology is the size and scale of the structures or buildings. Additionally, there is involvement of different trades in this industry. So as I mentioned, there are different trades collaborating with each other in the industry, in the construction industry, and there is a high resistance to some sort of change or even effective change in this industry. So this is another problem, the resistance against accepting the new change and moving forward. And the last but not least is all about the lack of trained and technical workforce. So currently there is just limited people who are has some level of knowledge about using this new technique in the construction industry. So as you see, there have been problems and difficulties in such a transition for construction industry. But recently, over the last few years, there has been development in the field of fabrication and construction that you might hear about 3D printing of buildings or houses. And I'm going to show a couple of examples in the next few slides. So here is, this slide shows a picture which mapping 20 years of 3D printing in architecture. It has started about 25 years ago in the USC by Dr. Khoshnevis. He was the first one who came up with the idea of using 3D printer in architectural scale. And as you can see at the beginning, it was very slow adoption and a study in this field. But in last few years, I would say 5 years, there is much more advancement in the use of this technology. And there is some sort of exponential growth in the use of this technology in the construction. And as you might hear, there are some companies in US or in Europe or China that they are doing the real scale construction by using 3D printing. So one of the important problems that 3D printing or additive manufacturing in construction might address that is all about affordable housing. It is so surprising that in 21st century, still about 1 billion people are living in slums or informal settlements and under any sort of substandard condition around the world. These slums are mostly occupied by very poor people and families who have nowhere to live. These slums area often suffer from crime, and that can be lawless and violent places for those people. People living in slums are more likely suffer from illnesses and also disease. COVID pandemic made this situation much more miserable for these people. The life expectancy of an average slum dweller is much, much lower compared to someone living in very standard conditions. So the growing number of slum dwellers is a result of both urbanization and also population growth. And it's one of the biggest problems that our world will face over the next 10 years. So currently there are 1 billion people who are living in substandard condition, and this number is going to also increase over the next years. So construction of new affordable house is the best solution to make sure all of the people in Earth have some sort of a standard condition for their lives. Compared to conventional method of construction, 3D printing in construction has a potential of automation, reducing the construction costs, especially in terms of labor and formwork and materials. We can have faster construction, lower material waste and energy. It can help us with fabrication of any complex geometry. So the construction industry needs to be adapted for this new construction practice to ensure affordable and adequate housing for everyone over the next 20 years. So in this slide, I'm showing some of the applications for using 3D printer in the construction industry. So as you can see, we can use this new technology for constructing emergency house for those who are victims of natural or man-made disaster. As I mentioned, conventional construction is very slow and it takes months or years to complete a construction. So for those who are the victim of any man-made or natural disaster, this 3D printing could provide very fast construction, maybe in a day or so, to have some sort of shelter for those victims. Another application, as I mentioned in the previous slide, is all about low income or affordable housing. So in order to make sure all of the people on Earth are living under some sort of a standard condition, we can make sure that we could provide some sort of affordable housing for even low-income people. For any case that we are considering environmental aspects, because 3D printing helps us to lower the amount of energy, the amount of material waste. So it would be very helpful to consider the sustainability in construction industry. Additionally, 3D printing is enabling humans to just construct any functionally graded structure. It means the composition of the material over the volume of the structure or building is changing from one place to another place. And it's impossible, but by using the automation and robotic arm, it enables us to have some sort of functionally graded material in construction industry. And the last but not least is all about the space colonies that I'm going to in much more detail in few next slides. So one of the questions would be which type of construction material can be used for digital construction. So there are so many cases, so many construction materials that nowadays is used in construction, and among all of them, concrete has high potential to be used for the layer-wise fabrication of a different structural part or building. And the reason is that this material is formable and shapeable in its fresh state. So this is a great candidate to be used in construction industry. Additionally, because concrete is not sustainable material, this material is responsible for 7% of carbon dioxide emission to Earth atmosphere each year. So this is not a sustainable material. Whenever we want to consider the sustainable solution for construction industry, we can use any sort of local material like soil. So these are some of the ancient buildings from 400 years ago. They experienced a couple of earthquakes and they stay very sound and healthy even after experiencing a couple of earthquakes. And it's all about the curvilinear structures that enable this structure to be resistant against any lateral load like earthquake load. In order to do this sort of construction, we need to have some skillful laborers, and it's not really easy to do this sort of construction by human. However, 3D printing enables us to do any sort of fabrication and construction for any complex geometry to form this structure. So we can use the local resources like soils and construct any sort of complex structure, which is hard to be constructed in the conventional way. So there are a couple of 3D printing companies nowadays, and the number of these companies is increasing exponentially from month to month. I just had 10 of them here in this slide, but if you check the Google, you can find more names, but these are the most popular ones. Some of them are US-based, like Episcore, Icon, and Contour Crafting are all a US-based company. And in this slide, in this video, I'm going to show some of the application of 3D printing in large scale of construction houses, offices, or affordable house. So this video shows the very first two-story building, which was 3D printed in 15 days in Belgium. So they showed that this construction used 60% fewer resources, 50% less carbon dioxide emission, 3 times a stronger material, and just 1% monitored the entire construction. So in this video, you can see how this method of construction could effectively use for construction of houses. Another example is in Dubai in 2019. So by using the Episcore, which is a US-based company, Dubai is aiming to 3D print a neighborhood by using this new technology. Another thing is about making the affordable house for French family. And also one of the US-based company, which is Icon, plan to make an affordable houses for a neighborhood in Mexico. So these are some of the examples of adapting this technology in the construction industry. So other than houses, there are some other applications. So this slide shows another application of 3D printing related to build tall concrete bases for wind turbines. Wind turbine tower have typically limited to the height of 100 meter or anything under 100 meter. The bases of this wind turbine are traditionally built in steel or precast concrete bases. However, taller tower could capture higher speed wind and generate larger amount of energy. So 3D printed concrete technology enabled the creation of cost-effective taller towers up to 200 meter, which is double or twice of what we have for conventional construction to generate larger amount of energy. So now that we learn about some of the current advancements on the application of 3D printing in the construction industry, we want to learn more about one of the applications of using this technology. 3D printing enables us to do construction of the Earth and in other planets where we don't have any human or labor to do the construction. So over all of these years, the last 100 years, there are many arguments have been made for and against this space colonization. So the most common discussion in favor of colonization is all about the survival of human civilization and also the availability of additional resources in space in terms of material and energy. So Dr. Hopkins, he was one of the famous physicists and cosmologists and author in the University of Cambridge. He predicted that the human race would become extinct within the next 1,000 years. And he said that humanity has two options. One is that colonize a space within the next 200 years and build residential units of the Earth. And the other option, which would be facing the long-term extinction over the next 1,000 years. So the resources in a space, both in terms of materials and energy, are enormous. The solar system, or outside of the solar system, there are several 100 billion stars which are observable in the universe, and they could provide opportunities for both colonization and also resources collection. All these planets and other bodies offer virtually endless supply for human colonization. And it's the reason that NASA administrator identified colonization as the ultimate goal of their space flight program. So the solar system alone has enough material and energy to support anywhere from several thousand to 1 billion times that what we currently have on the Earth-based human population. In the solar system, we have the inner planets, which are much closer to sun, and in order of the distance from the sun, from closer to furthest, we have Mercury, Venus, Earth, and Mars, followed by the asteroid belt, and comes to the other planets which are further away from the sun, and we have Jupiter, Saturn, Uranus, and Neptune. So these other planets are all further away from the sun, and also they are larger and mostly made of gas. So the location of colonization for the human could be any physical body of these planets, their natural satellites, or asteroid belt. So these are some of the options that NASA is considering in their current study for colonization. So the nearest space to Earth is Moon, or one of the inner planets, which would be Mercury, Venus, or Mars. They are also doing some study for the chance of using the resources on the asteroid belt, and also for the moons of other planets, like the moons of Saturn, is the interest of NASA studies. So for now, the majority of effort is focused on the near Earth space like Moon or Mars. All right. So NASA and its partner were holding a 2.5 million competition to build a 3D printed habitat for deep space exploration. They invited the idea from industry and academia to help and bring new horizon to the challenges related to making this real. So NASA designed a multi-phase challenges. So first of all, speed up the adoption of this 3D printing technology for the Earth project. And secondly, make some advancement for habitation of deep space. So this NASA challenge was started in 2015. It was multi-phase, and I'm going to review some of the phases of this project. So what I'm presenting in the last part of my presentation today will be focused in part of my experience that I worked during my PhD and also postdoc at Penn State University to work on 3D printing technology and design and build Mars habitat. So it was all in response of this NASA 3D printed habitat challenge, which was started in 2015, and Penn State team participated in multi-phases of this challenge. So whatever I'm presenting in the next few slides is a teamwork, which has been done by a team, a multidisciplinary team of faculties and students from different engineering departments like civil engineering, engineering design, electrical and computer engineering, and also Department of Architecture at Penn State University. So an interdisciplinary team worked on 3 interconnected areas, including material, mechanical system, and design to use 3D printing technology for designing and building Mars habitat. So one of the areas that we started our study was all about the materials. So this was one of the important categories that we need to answer or address in order to be able to use 3D printing in the construction technology or industry. So as I mentioned, for the Earth construction, concrete is a great candidate. It has great potential to be used as a construction materials. And what is concrete? Concrete is made of cement, water, and sand. Cement and water works together to make a glue or binder and hold aggregates together to form an artificial stone that we call it concrete. But when it comes to Mars project and construction in Mars, it doesn't make sense to transport material from Earth to Mars. So one of the reasons that we are talking about colonization is using their resources and their energy, right? So if we want to transport the material, what is the point? NASA, in the NASA Habitat Challenge, asked the teams, the industry, and also academia team to design some material from the indigenous material available on Mars surface. So one of the reasons behind the habitation of the air of other planets is using their resources. And because of that, we need to design some material, some construction material from the indigenous material available of the Earth or on Martian surface. So because there is limited resources of calcium-bearing minerals on Mars, producing Earth cement would be impossible. Additionally, when we studied the NASA report about the resources available on Martian surface, we saw that underneath the layers of dust on the Mars surface, there is a 30 to 100 kilometer thick Martian crust, which is mostly consists of volcanic basalt. So this volcanic basalt rock could be extracted and crushed and be used similar to the aggregate like sand or gravel that we are using for the Earth concrete. So this is one of the resources that we could use to make Martian concrete. Additionally, kaolinite, which is a layered silicate clay, is the phase which is available on some specific location on Mars. This is based on the NASA study and reports. So if we can extract again this material, this clay, do some calcination or calcine this material at higher temperature, we can form metakaolin. Metakaolin is somehow similar to cement. It could be activated by using some other compound, silicate or calcium compound, to form some cementitious property. Additionally, the NASA data shows that the Martian regoliths hold sodium and silicon compound. This compound could be used to activate metakaolin. For this study, we assume that we are also able to use 2% frozen water, which is available on Martian condition. It was our assumption. No one yet know that how we can extract this frozen water and use it. It would be in the future research of NASA, but in order to develop some Martian concrete, we had no choice but assume that we are able to use this 2% water. So considering the composition of the ingredients that I mentioned before, the indigenous Martian minerals that I explained in the previous slide, Penn State team designed a geopolymer-based concrete and call it Marscrete. So you can see the composition of this material, which is made of basalt, volcanic basalt, like 64% is made of basalt, and the rest is metakaolin and some other minerals that could be synthesized from the Martian regoliths. So we answered the first question by NASA challenge, which was all about how to design the proper material for Martian construction. The next step of our project was working on the system. So we started this project at Penn State University in 2018. 2016. At the beginning of this project, we were using a small robot, ABB robotic arm. We have a small pump, and we also use this Hobart mixer because the size of the construction was small at the beginning of this project. So in phase 2, level 1 and 2 of the NASA challenge, NASA asked the team to print a cylinder, beam, and cone by using this Martian regolith source material, or Mars grid, that we developed in the previous step. And there was some post-test, mechanical tests, to make sure this material in terms of mechanical properties comparable with the cement. So Penn State team was able, after so many trials, we were able to adjust the property of our material to make this material printable. We printed a cylinder, a beam, we measured the strength of this material, and we successfully be able to pass this level of the project. The next phase of the project was about 3D printing of dome. So in order to do that, we scale up our system. We purchased a larger robotic arm, ABB robotic arm. Instead of the pump and mixer, the tiny one that we have, we purchased a dual mixer and pump system. And we were able to finish the level 3 of NASA challenge in phase 2. It was a head-to-head challenge in the Caterpillar Visitor Center in Peoria, Illinois, in September 2017. We were able to 3D print this dome with the material, and the dome that we printed passed all of the mechanical tests by the NASA judge, and we were able to win some prizes at this level of NASA project. Phase 3 of NASA project started in summer 2018. In the first step, they asked the team to 3D print the foundation. The main goal of phase 3 of NASA challenge was autonomous construction. They asked teams to minimize the human involvement, and mainly we should train robots to do the majority of the construction. So because of that, we added some part like the silo to make sure there is no human involvement during the printing process. So we passed all of the post-tests for printing the foundation. We won another award for this phase of the project. In level 2 of phase 3, NASA asked the team to 3D print a water tank or system. Again, this printing should happen all autonomously or without any human intervention. And because of that, we had this silo added to our system. They asked the team to place 2 pipes on the wall of the system. And there was some post-test after finishing all of this construction to make sure the printed structure is meeting all of the requirements. One of the tests was the hydrostatic test or the leakage test over 15 minutes. And the water tank that we printed in this phase were also able to hold all of the material, all of the water over 15 minutes, and we passed all of the requirements for this phase of the project. So this slide shows our printed tank. It took about 1.5 hours to finish the printing of this tank, this size tank, and we passed all of the post-tests, including the leakage test, which was assigned by NASA. We won another prize in level 2 of phase 3 for NASA project. In level 3 and level 4, NASA asked the teams to design shelters for humans to live on Mars. So they asked the team to design a 1,000 square feet of living space for 4 astronauts. We should also consider and include the life support, mechanical, electrical, and plumbing, and also safety and entry and exit system. And this is whatever Penn State team did in the virtual construction phase of this project.
Colonizing space is the next great leap for humankind.
So let me just turn it off, then we can hear.
Mankind. Of all the inner planets in the solar system, Mars, the red planet, is most similar to Earth and considered the best option for human colonization. An abundance of material construct a permanent habitat, a first step toward a human settlement, but you need a place to build. Scanning the surface of the planet, one location for our permanent station stood out, the Endurance Crater. Conditions on Mars are inhospitable and pose big challenges to human life. Because of the expense and limitations of space travel, we will need to maximize the use of indigenous materials and resources. Our strategy builds on our current research to develop low-cost housing on Earth using parametric BIM design and additive manufacturing. The construction process involves a robotic arm printing a geopolymer concrete mixture called Marscrete. Marscrete consists of indigenous minerals, including basalt, which is crushed and used as aggregate. Kaolinite has to be calcined to obtain metakaolin, which is used as binder, and sodium and silicon compounds, which are used as agents to activate metakaolin with water, obtained from ice. We understand the hydration reaction with gravity by studying the solidification of concrete aboard the International Space Station. Another key aspect stems from our research on the development of graded composite materials that permit a seamless and impermeable graded transition between opaque and transparent surfaces, such as our engineered geopolymer concrete and borate glass. The composite material is lightweight, thermally insulative, resistant to chemicals, freezing, and fire, as well as impermeable and protective from cosmic radiation. This technology promises to have significant impacts on building processes, architectural language, and the spatial experience of dwellers. The design concept considers the maximum angle that can be printed without formwork, the minimum wall thickness required to protect from radiation, the maximum reach of a robotic arm, and structural stability. The result is a basic unit formed by a cylinder and a cone. The finite element analysis considered the principal tensile and compressive strength, considering the interior of the building will be pressurized. This conic unit can have varying sizes and be connected and combined in different ways to obtain different shelter configurations, adjusted to different programmatic requirements and specific site conditions. These principles guarantee expandability as more units are added to the original design. Among multiple possible design options, we chose one to illustrate our concept. Each unit is composed of a protective shell made from indigenous geopolymer concrete and a lighter interior constructed from both indigenous geopolymer and recycled plastics with 2 floors. By manipulating the seamless transition from geopolymer to glass, we can provide 2 types of openings. From above, giving each unit ambience lighting, and from sideways, allowing for views towards the Martian landscape. There are 4 units for work, living, sleeping, and gardening. Entry chambers on each end of the habitat enable access from the exterior and emergency exits. The first unit includes a wet lab, meeting area, and storage on the first floor, and individual workspaces on the second floor. These 2 different workspaces are articulated by a staircase. The second unit hosts the dining area, the kitchen, and bathrooms on the first floor, and a leisure area on the second floor, accessed by a second staircase. The third unit includes the sleeping quarters on the first floor and workout and leisure areas on the second floor. The design was conceived to enable visual communication between the various units and floors, thereby offering a spatially rich living environment. The fourth unit contains life support and hydroponic systems with provisions for emergency situations. Each unit can be sealed and will have life support capability during repairs. The printing system is mounted on a rover. It includes a retractable dome that guarantees proper conditions for printing. Once one module is constructed, the rover moves to print the next module. This strategy will enable the creation and growth of thriving human colonies on Mars.
So this was part of what Penn State team for the virtual construction, and finally, for the last level of NASA project, NASA asked the team to 3D print one-third scale habitat that they designed in the previous phase. In order to reach full automation, Penn State team was adding some part, including second robotic arm, a big silo, which autonomously provide required material to the pump. We have big water tank. Again, everything was autonomous. It was designed somehow to work without any human intervention. So one of the robotic arm was doing the construction while the other robotic arm was in charge, and it was trained to place any sort of opening during the construction on the wall of printed habitat. All of these person that you see in the construction sites, there were crews that has minimum or zero intervention during the construction process. So it was a head-to-head competition, which was done in the, again, Caterpillar Visitor Center. It was a big warehouse in Peoria, Illinois in May 2014. Among 64 teams, just 2 teams were able to make it up to the final level. It was Penn State team and some team from industry. And in the next slide, I'm going to show you how we did this phase of the construction. So this is the picture of this big warehouse in the Caterpillar Visitor Center in Peoria, Illinois. And this is the final structure that we were able to 3D print that. Because we don't have time, I'm going to skip this video and just, I will show you the short video which was done by NASA. So as I mentioned, 2 teams make it all the way to this final phase. One was Penn State team. We use the geopolymer-based material, and we have a modular construction. The other team was Space Factory, and this is the habitat that they designed. Each team has 3 days, each day 10 hours to do the construction. Again, the big goal was achieving the full automation or autonomous construction. There was some post-tests, including the drop test, the crush test, and smoke test. And finally, Penn State team was able to achieve and won the second prize, and Space Factory won the first prize of the NASA project. So just to finish my presentation, currently I'm working with a team of students at UNM on 3D printing project. So one of the coolest projects that I had a chance to be part of that was working with the NASA Minds Challenge. So I work with a team of interdisciplinary researchers at UNM to teach robots to take care of plants on Mars. So, and UNM team won the first place award last year in spring 2021. The idea about this construction is all about making a chili house on Mars by using the indigenous material. This is part of the pots that we printed by using the printer that we have at UNM. And then we can take care of the chili house, the New Mexico chilies, which is designed to be grow on Martian condition. And we take care of these chilies by using swarmy robots, which are a smaller, simpler machine compared to the current Mars rover, which is used on Mars. So these are some of the achievements that I had with the NASA Minds team at UNM. And still we are part of this NASA challenge this year. For another phase of this project, I'm working with a team of engineers in the computer and electrical engineering, and also architect in Department of Architectural and Architecture to do this interdisciplinary project. So these are some of the work that I'm doing with my team. We are working on designing novel and sustainable material. We adjust the property of this material for printing. And there are some other projects that I will do in future, including enlarging or scaling up the printing system that currently we are using at UMM to be adjusted for autonomous construction. We are taking care of 3D printing of earthen structures because New Mexico is the home of adobe structure. So we can use the local soil to do some sustainable construction. And also to do some affordable construction. At the end, I want to thank you all for your attention, and thank you Albuquerque IEEE WIE for inviting me to this event. Thank you so much. I will be happy to answer your question. My email and information is also provided here. I would be happy to meet you in person or over email to answer some of your questions.
Thank you, Dr. Maryam. It's a very interesting and very nice talk. I personally enjoyed a lot. Let's see if our audience has any questions. So any questions from audience?
Okay, I can start to break, I guess, the ice here. So the technical talk was so interesting, and really as an electrical and computer engineer, I'm quite excited with the things that you are doing. So Maryam, because this is also, a talk not to inspire our young students and young professionals that are entering the field of, any engineering field. Your trip was quite challenging. I mean, coming from Penn State to UNM. So what you can comment on, like, was your major challenge, and what things helped you in order to overcome those challenges?
Thank you so much. And so one of the biggest challenge in this type of research is all about the interdisciplinary research that we are doing. So it's multidiscipline between different engineering and architecture major, that we should find some common language to understand each other. So when I started this project like 6 years ago or 7 years ago, it was a bit difficult or challenging at the beginning to understand other people or try to solve a problem all together. But over time, we learn how to work together as a team. We have some like basic knowledge in other discipline to be able to make sure we are able to move forward for any biggest challenge. So one of the interesting part in the use of 3D printer in construction is the nature of this research, which is highly interdisciplinary. It's not just for civils because it's construction. It's for all different engineering major and also architecture who could help us for pushing the boundaries of this new and novel technology and move forward.
Thank you, Maryam. So now I will pass the torch to somebody else that has a question for Maryam.
It seems Bob has a question.
Sure, Bob, go ahead.
I can actually ask a question. So as you said, this is a very interesting talk, and I actually do not have that much background on this 3D printing. So, but I am curious from your talk. One thing I noticed that you probably this 3D printing technology probably is limited to the materials, right? So I saw that you used concrete a lot and then probably plastics. So this is one thing. And the last video I saw, probably it's in Belgium or probably the last one, I think. What is your thought in future for, I think it's also reducing human labor. I remember in the Belgium video, you mentioned that the whole project was conducted by just one person. So what do you think that because it's reducing the potential, reduction of human labor, and then, so that is one thing. And the second thing is that the engineering compatibility in terms of the whole entire design, in 3D. So sorry, there's a lot of questions probably. Yeah.
Great questions. And this is the question that so many people ask me about. So what would happen to the laborers who are working in this industry? So one example that I would say is about the transition that we have in the agriculture. So if you compare what's happened over the last 100 years in the agriculture, it was mainly done by human. It was mainly manual, but over the last 100 years, there was a transition from manual to automation. And most of the people start to be trained to how to use this new technology. And so there would be new jobs, definitely, that need some sort of training, but we are providing by this technique safer environment for doing the construction. I agree with you. It's maybe at the beginning, it's a bit frustrating that what will happen if we want to cancel all of the laborers from the construction site, but there would be new jobs similar to what happened to agriculture. So there would be new jobs, which is safer, much safer. They are not exposed to any direct danger, but they could train the robots, work with the robots, and something behind the scene that we couldn't see them maybe in the construction site. But still, 3D printing in its very first steps, it has not commercialized yet. There are so many studies to just show the capability of this new technique for construction of the house. It's in very early stage. We could not even claim that it's a replacement for conventional construction. We need to make sure in terms of material property, in terms of long-term durability, we have something comparable with the conventional or traditional constructed structure. So at this moment, I couldn't even claim that by using 3D printing, we could have some replacement for traditional construction. This is just new construction techniques. It could be used for some specific application for now, but in the future, as we have better control on the material, on the system, we might have better answer if it is a good replacement or not.
Okay.
Well, oh, yes, go ahead. Yeah,
hello,
sure.
Maryam. Actually, one of the pictures you used there, I think it's Lagos, Nigeria, because I actually grew up in that kind of environment to see how people live in slums. And I have never been able to understand it, but I have seen it. And it is crazy. So, and I'm taking a class this semester with Professor Mark Goldman about building and using other materials in terms of, bridging the gap of inequality in the world. My question would be like, where are we right now in terms of building with mud? Because I don't know how the 3D technology has done in terms of building residential buildings with mud in terms of Adobe. Where are we in that situation right now?
So thank you, Bob. I have some problem to hearing your question fully, but you ask about the material to make affordable construction.
Yeah, for 3D printing, how far has 3D printing gone in building Adobe buildings?
Right.
Is there a kind of, would I say group of people doing something with 3D printing of Adobe buildings right now?
Right. So one of the reasons that also, thank you for your question. It's a great question. One of the reasons that I also talk about using local resources was about the sustainability. Using cement in the construction. So as I mentioned, concrete is made of cement, water, and aggregate. Cement is not a sustainable and green material. In order to make cement, for each ton of cement, it emits 1 ton of carbon dioxide to the atmosphere, which is significant. And so we need to find some other alternatives, some green resources to make sure we are not just increasing the amount of cement which is used in construction industry. So one of the sustainable solution is just using the natural resources like soil. If you add water to soil, for some specific soil that we also have those material available on New Mexico. New Mexico has a great soil that could hold great property and use for construction. Yep. So material have some sort of plastic property that we could form it similar to concrete. So as long as in the fresh state, this material is formable and shapeable, it could be used as a resources for construction. And it's natural, it's sustainable, it's green, but still we need to study the property of printed material. Since it's completely different than traditional construction, we should make sure it's comparable, or we can adjust its property to be comparable with the traditional practice.
Oh, okay, great. Thank you very much, Maryam.
Thank you so much for your question.
So I have a couple of questions here. So thank you so much, Dr. Hojati, for your informative and comprehensive talk. So you have mentioned about the 3D printing for the houses. My question is, do you have only one big 3D printers, or you have multiple 3D printers that are collaboratively work together to build this house?
Thank you, Dr. Son, for your participation, and thank you for your question. Actually, it depends on the scale. So if we are talking about larger scale, definitely multiple printer would work together, because one of the problems that we might face in 3D printing would be formation of cold joint between the old material and new material. So the joint between the old printed material and fresh material could form some sort of cold joint, and it would be some level of weakness for a structure. So if we increase the number of robotic arms to do the construction, it would help to improve the mechanical property in the later stage. But again, it depends on this scale that we are working. So there are some of the companies that they design some sort of rail that their robotic arm is able to move around the construction site and take care of the construction. So there are a couple of methods, or there are some sort of gantry printer that has a couple of nozzle and extruder to do the construction. There are different methods, again, depending on which type of what is the scale of construction. We could have one or multiple robotic arm to take care of the construction, especially when we want to add like the opening, similar to what I showed you earlier about the NASA project. We added new robotic arm which was just trained to place the opening, the window, the door in the geometry that we design or we program it for that.
Okay, so what is the biggest challenge to control of the 3D printers? I know that there's a trade-off between the speed of the printing and the vibration of the printers, which will degrade the performance of the material. So I don't know if there's any existing models can optimize this trade-off, such that the 3D printing can have its largest printing speed, and also it can guarantee the quality of the material.
Right. So it was, again, very great question. One of the biggest challenges in the 3D printing is, first of all, the property of material is time dependent. So from time 0 that you mix the material to like 1 hour, 2 hours, 3 hours, this material property is changing in terms of their plastic property, the amount of water that they have, the printability, the extrudability, the fluidity, these all changing from time to time. So if we can formulate this material property as a function of time, again, another challenge would be ambient condition. So ambient condition could also affect the material property. So if you do the printing at very low temperature, you're gonna get different results compared to when you print your structure at very high temperature. So these are something that should be formulated and consider all of the condition. Then through an automated system, we can say, okay, the temperature is like 21 degrees today. This is the size of the structure, so we should consider all of the change in terms of the geometry that the material would experience in terms of fluidity, printability, extrudability, buildability. These are important terms that we should consider.
Sorry, go ahead.
Another variable is all about the printing speed that you mentioned. Mm-hmm. So there are 2 other variables related to the system. One of them is the extrusion speed, which is all how fast we extrude the material or slowly extrude the material, and also how fast the robotic arm is moving. So sometimes if we don't adjust the extrusion speed and printing speed, the speed of the robotic arm, we're going to have over extrusion or under extrusion. Again, these are something that should be adjusted by having an understanding the time-dependent property of the material, by considering all of the ambient condition, the temperature, the relative humidity that could change or be another parameter or variable in our formula. So we have some formula with so many variables that if we could control all of these things, we can make sure that our system is fully or completely autonomous and automated.
So do you think the existing machine learning method can be used to solve this kind of modeling problem?
Right, yeah. This is something, there are a couple of papers recently, they published that. But you know, in order to have this machine learning technique, we need to have so much information, right? Still, there is some lag in terms of like big data that enables us to predict all of these things. But yeah, this is a great technique that would help us to formulate all of these so many variables and help us to make an autonomous printing process.
Thank you. Thank you for your answer.
Thank you for your participation. Great to see you here.
Yeah, thank you. Thank you, Dr. Maryam. We're a little over time hours, so maybe we can take one more last question from audience. Actually, I see a question in the chat window, so if you don't mind to take it, Dr. Maryam.
When do you expect NASA to actually go through with the plan of? I guess so. There are so many about NASA construction. There are so many questions. One of them is that, first of all, the ambient condition is completely different on Mars, right? So the temperature is much lower, right? And the change of temperature from day to night, again, is another thing that we should consider. The pressure is very low. The gravity is different. So I guess it takes a while to answer all of this question. Whatever we did in the design of like Marscrete or Martian material, we just assume we can synthesize this material on Mars surface, but we should just design an autonomous process to do all of the synthetic or all of this material production. There are so many questions about NASA project, and I know, as I'm aware, there are so many teams that work all together in parallel way to answer this question. So the big plan is by the end of 2025, they're gonna do something on Moon, but I don't know how much we are close this today. hopefully it will happen soon.
Okay, thank you again, Dr. Maryam. So, and audience, once again, many thanks for your presence and interest tonight to make this event successful. And of course, we would like to express our gratitude to our Albuquerque IEEE section, as always, for their support to make this event happen. Let's thank our speaker one more time. It's the virtual. With that, I hope to see you all in next month, and you all have a wonderful night.
So one thing, James, if you email me, I can provide more resources for you. My email.
Yes, I see a question in the chat window. Yes, can you please? Okay, there you go.
Okay, yeah. Thank you, everyone. Have a great night, and thanks for inviting me. I had a great time tonight with you. Thanks, Ernie.
Thank you. Bye.
Bye. Good night, everyone.